Okay, test. Waiting for Twitch to catch up as usual. Okay, perfect. Hello everyone, welcome back to the project. Sorry for the long absence. I've had health issues to deal with, and when looking at a screen for more than 10 minutes is difficult, doing a stream is a bit impossible. So sorry for the long wait. This puts me in a very difficult situation where, after a few weeks of not being able to look at the screen, I have to jump back into this project that I abandoned in the middle of a refactor, which means the code does not compile. It is in a state where nothing was working, and we have to jump back in. That's going to be fun. So, the gist of what we were doing last time, probably around a month ago, was we got to a point where most of the phases of the compiler were working. We had the IR generation working. But I went back to the analysis phase. The analysis phase is where we take the AST that has been passed and we check for, like, we do name checking, validation, and so on to ensure that what has been passed makes sense before we go on to lowering into AR and then generating the code. I wanted to refactor it because there was a few things in the representation of that phase that were cumbersome. Places where we would check something, but we would not persist that check, meaning it had to be checked again at a later stage. So what we started to do last time was a big refactor of the entirety of the analysis phase, splitting it into two, into the name resolving first, and then the analysis validation part. We left in the middle of the refactor, and my job this evening is to go back to that refactor and figure out where we were and to where to continue. So yeah, let's go. Oop. Let's go here. So last time we finished, I think, the entirety of the resolution phase, where we translate the name of everything we find. So as far as I remember, this resolve phase is finished, and at the end of this we have the resolve state of our AST, where everything has a name that uniquely identifies the thing within it, which was part of the work we're doing as part of the analysis, and now in a separate phase. If I remember correctly, we had starting writing the validation phase, which does the everything else. Something we don't have in this version so far, but we might not need. We had checks for circular definitions in the old code for the analysis. Will we need that is in this new separate version? We might not. I'll have to think about it. We were in the middle, I think, last time of a validate type function, because I see here this does not compile, this is not valid syntax. So let's start here. Even though this might not be what I want to work on, at the very least, let's make it compile. Well, compile. Let's make the syntax, let's make it pass at the very least. So I suppose this is going to be the same thing. Finding a constant is not a name. Finding a function would not be a valid type. A function type would be valid, but that's different. Finding a type alias, would that be valid as a type? I don't know. I guess it would be fine. Like, this thing that we have resolved happened to be a type alias. We can therefore do the type resolution and point to, I'm gonna make this as a unimplemented, but I think it will be valid. A type parameter will be valid, except this will be a case where, since we no longer do any type checking of generic functions until they are instantiated, if we ever find something that is a type parameter, we should be able to point to we should be able to point to the exact concrete type, which will require having that in the context. So valid, but not implemented yet. Placeholder, absolutely not valid. Should never happen. In a normal call to validate type, I suppose. There will be places where a placeholder will make sense, and that's something we'll have to figure out. But I think for now this is valid. A function pointer to a function type. Now, that is a value. I don't think this makes sense as a type. That being said, do I have a way to represent a function type other than the function pointer like this? Let's see, since again I left this work in the middle of refactor a month ago, I don't remember how much we had done actually at that point. So let's have a quick look at the representation, because we had created a new representation for the output of this phase, which I think was called the interface. And where had we defined type? I do not remember. There will be more than one, but is that in the IR? Where is the type coming from? That feels surprising. I think it's supposed to be an interface at some point, but I just don't have a type there yet. Because I think the type I have is currently the one that's in the IR, but that might not be what I want, right? Or is it? It might be different, and therefore I might want to use a duplicate type for when I want to introduce differences, but it will be, I think, overall extremely similar. Okay, so I do have, and this is a path info that we have now changed, which points to a role. And a role is now defined as part of the AST, I believe. Oh. Wait, why is all of this? Oh, because, yes, of course. I split the AST between past and resolved. And here is the role indeed. So I suppose, what would be, how do I obtain something that has a type, function type? It cannot be from a variable. It cannot be, so it has to be a function pointer, I suppose. So the type of that thing will be a function type. But does that mean? That means basically, okay, I have a variable that happens to be, I guess its type will be function pointer, and therefore that's a valid type. So that means here we must accept it and translate that into the corresponding type representation. Okay. A function argument, that is not a type, that's a value. That's an error. Likewise for a let variable. Okay. For now, I'm just going to okay. I think even though there's so much we have to do to make progress on this, I think I want to try to migrate the old validate const expression function, because this is going to be the same thing minus the resolving, which means we can try to move the old code, and it's gonna like make us confront a lot of the issues we have, because we're gonna have to go through a lot of things. So unless I want to move that into a separate file, which maybe I do, maybe not for now, and we'll see. So I'll go back to old core, const expression. Huh. I think the const expression was always an as part. Yeah, there we go. Go here. So this go function, this gigantic thing, I am going to copy into here. This will be a validate const expression. I've been thinking about, do I use this opportunity to deduplicate validate expression between constant and function? And I feel like it's easier not to, because there's a lot of things that are just simply not valid in the case of a constant, and I could just apply a validate expression on a constant expression and then try to evaluate at constant time, at compile time, and then just throw an error if I cannot. It might be easier to just throw an error ahead of time if I encounter something that just cannot be passed as an expression at compile time. The downside being that I end up doing a lot of duplicate work. What I might be able to do, however, is move a lot of the code to smaller subfunctions, like validate a cast expression, validate a struct expression or something like this, and in the case of a constant, then check that the value is known at compile time, that it doesn't contain anything that could not be evaluated at compile time. That is an option, and I think that's the easiest. So given for now the little that we have, in terms of constraints, there's going to be more constraints there probably. This will be containing, is that just an annotated typed expression? Or have I changed this as well? I might have. Let me actually quickly check that. If I go to resolved, roll here. Okay, so it's not there. I don't have anything about the... interesting. Does that mean I no longer have any annotation in my AST? That's surprising. Or does that mean I just have not migrated things here? The problem of abandoning a project for a month in the middle of a refactor. Let's see if I look at typed expression. Wait. Oh, this, okay. And there's must be a common one. There is a common one. There we go. Expression is there. But expression is no longer... I no longer have a typed expression. I guess, no, of course that makes sense. As part of the resolving process, I will no longer... Yeah, the type will be part of the analysis. So that makes sense. That makes sense. So what I will have here will be an expression resolved. And this function will be about looking at the different cases and deciding which ones are valid in the context of a constant. Do I have in my validation monad I have a current location. Okay. Do I want actually to change that by looking at, if I look at a constant, the expression will be a with location, so it contains the location information. And likewise, everything else contains the location expression. So it might be worth it to here take a with location. Is that the proper? I think this is wrong, and I think this is because of some eager replacing. I think all of this is the wrong syntax. I think this will be correct. Because with location only expects one parameter. Yep. So all of those are wrong. Okay. Let's start there, I suppose. Actually, I guess I could try. Okay. So that's better. So we can change that in here as well. And here that means that we always start. So I have a with location object as an argument, and I always start by setting the current location for error reporting to where we are, which if I look at the monad will be the current location. And then I can do a case of the thing that is at that location. And here is where we have this big case where we're going to have to decide if any given expression is valid in this context. There's a bunch. There's a bunch of things that have changed, so a lot of things will no longer be valid. I guess this is true in the sense of like, we're going to want to decide, is this value here a valid value in the context of a expression, in the context of a constant. Have I not? I thought I had made a slightly different expression type for the resolved thing. No, it may be part of the interface. Or maybe I haven't done that yet, but that will be part of the work, to add another layer of translation where the output will be something a bit different, because maybe we can preserve more information there. Like, for instance, I can validate that the path info here is correct in the context of a constant, and I can maybe, therefore, use a different representation for the output of the validation phase that encodes that with a different type of expression in which we represent that thing differently. I think I want to do that. I think that was the whole point, to avoid having that kind of thing. I thought I had already started with this. I'm surprised to not see that in here. It's not resolved either. So it should be in interface, but I don't see it in interface either. Huh. Because here's my point. At the end of the name resolution phase, we know that, okay, this path in an expression happens to be the name of a variable, or the name of a function argument, or a type alias, or something like this. But not everything makes sense as part of an expression. As part of an expression, for instance, a type alias makes no sense. That's not something that's valid there. But if the output of my validation phase contains something that still contains a role, then in subsequent phases, I will have to redo a check of like, oh, I have an expression that contains a role. I know for a fact that if it passed validation, then that role cannot be a type parameter. But as far as the language is concerned, that will still be a possibility. So the whole point of splitting those phases was to create a new output for the validation phase, where instead we have a different type of expression in which we cannot represent things that make no sense. So I'm surprised. I thought that work had started, but I don't see it. Let me just try. No, it's only there. I do have a typed expression still. Interesting. Oh, but in the commented version, of course, yes. And in common, I don't have oh, I'm doing a git grep. That's a mistake because not all files are in git. That might be my problem. There we go. I have checked, which is the third step after resolved, and that's where I have my new expression type. I knew I had done some work towards that. Okay. And maybe I already have a type there, and not an interface. I do indeed. Okay, perfect. So this can go away, because in checked, which is here is where I have different things altogether. I have this new type, and I have the new struct info, function type, and so on. I have the things that I need. And all of this is expressions. And here I have my typed expressions back. Okay. And here, again, I no longer have path with some arbitrary path. I have local variable, or maybe a function argument, or something like this. A function name is a wrong example. Reference argument is one. But where, I guess a normal argument will just be considered a local variable, which makes sense. Okay, let's go back to validation. So here, this will be purely, name resolving is now done. This will be purely about deciding, is this a valid value? And if yes, then what is the new representation instead we have to use instead? So here, this is, I'll have to specify. How do I name this? Because I will want to distinguish between expression in the input sense and expression in the output sense. So I will want to namespace them so that I always say, oh, this is an input expression. I guess just input output. That's the most explicit I can be. Which means this is an input expression. And the result of this will be an output expression. So here I want to write it inline? Because here again is the thing of like, do I want to share this piece of code with the code that is responsible for a function? Because in the case of a function, more things will be allowed than in this context. So I think I don't want to share the code. I do think it makes sense, however, to delegate it to another function to avoid cluttering this particular already pretty big case switch. Here, I'm tempted to move all of this. For a cast, however, I am very tempted to move all of the casts to a separate function and then just check when I have validated the cast that all of the types are known at compile time. Which, in the case of a constant, since there are no type parameters, like the type resolution has already happened, I think there's no point in duplicating the code. Since the type must be known for the name resolving phase to have succeeded, the cast must be valid at compile time. So, all of this can just go away in favor of a shared function that I will write at some point, but that will be shared with functions, which is just resolve cast. Or actually, not resolve. We have moved to validate at this point. And there will be, I suppose, some post-processing there. We will need to check. Will we? Or is it impossible, given name resolution, for it to be wrong at this point? No, I suppose. Well, there's one thing I have to check is, was I performing any substitution at that point? And since I'm already, I'm gonna do it anyway I'm gonna do it anyway. I guess I will have to do a check that what I have obtained is a constant time value, which should always be the case, I suppose. So I will probably have to do checked cast is this, do something here with it, like actually check that it is an actual authorized value and return that checked cast. But that is to be done later. Okay. And I guess everything else, that seems too short. Yes, I've definitely removed too much. We've moved all of this. By mistake. So let's put it back. Hello, how are you? Okay, so a field access expression. There again, do I need to do anything specific for a constant, or can I delegate this to a shared function that will deal with both constants and functions? Is there anything specific about checking? And I think, yeah, we did some work a few streams ago. So I think at this point, a month and a half ago, about having proper internal compiler errors rather than just like me panicking every time there was something wrong. Which, by the way, is what inspired this gigantic refactor I started a month ago and then abandoned because I could not continue streaming, which means I am left in the middle of like, what was I doing last time? Because what I realized is putting this proper panic handling in my IR lowering code, I was putting a ton of checks like this because the output of the analysis phase was not persisting a lot of the checks that were performed during it. Like I check that this thing is valid in this context, but I return something that does not represent that that can represent other things than just the valid one I've checked. Meaning code down the line must be like, oh, I have to handle the other cases, even though I know they're impossible because we are past the check. So I have to panic. So my goal was like, okay, we have to remove all of those panics by having the analysis phase output something that encompasses, that encodes all of those checks that have been performed. Hence this refactor. So here I think I'm going to do what I was saying for like most of those, where there is very few cases where it makes sense to try to like to re-implement the same thing across functions and constants, because a field access just means, okay, on the left hand side, I have something that happens to be a struct. On the right hand side, I have a name of something that belongs to that struct. I check that this is valid. I will do that for functions already. And I always do at this point already anyway. If I can resolve this at compile time, like I know the value of the struct on the left hand side, then I just return the actual value. Which means I don't need to do this. I will do the exact same thing. This will be a checked field, which will be the result of validating a field access. And here, likewise, check that this is a compile time value, that we don't have anything that's somehow compiled despite not being ignorable at compile time. And then we return that thing. Give me 1 sec. Yep. Next. A call expression is easy. A call expression means we're trying to call a function. That's why I'm keeping this function separate from the validate function, for validate expression that is used for functions. Function calls cannot exist in a constant. So that is a trivial case of that's a fatal error. We don't have an error for this yet, which we should fix. But this is a very simple case of like, you try to call a function in a constant expression. That makes no sense. array expressions are not implemented yet, but I suppose that I can do the same thing. Wait, why is array expression... Oh yes, because an array expression would be something that creates an array. Can I... Oh, actually there's something wrong here. Aha. Here I'm saying, oh, I'm delegating to other functions, and that's fine. The problem is, I will need to know what function to call recursively to analyze sub-expressions, because sub-expressions will either be constant or functions. So that means that all of those, if I want them to be shared, need to know what function to call recursively. I feel like there's probably some fixed point shenanigans that we can use here to avoid having to be... There's probably some shenanigans we can do here. That, or I give up on the idea of sharing code across... Yeah, that makes sense. I definitely will want to keep type information moving forward. That's the thing, is like, what I had before this refactor, what I had in the output of the analysis phase was something that had the type information, but also contained had a lot of possible representations of things that were invalid. If you look at this role type in resolved now, which tells me, oh, this name in this context, what is this? And a name in a given context can be the name of a constant. It can be a name of a function argument. It can be the name of a built-in function. It can be one of any of those things. What does that name mean, basically, in the context? However, since my representation in the output of the analysis phase was still using this, I would have things such as, oh, the left-hand side of this expression, of this plus expression, which adds integers, it's a role, so it could be, a struct. Since I've already done the analysis phase, I know that the left-hand side of a plus is not a struct, because that would have been rejected. But the types that we're using would not be able to capture this, which means my lowering into AR would see a plus between two ints and would have to do a case on the left-hand side and be like, is this a struct? If it is, internal compiler error. Hence, keeping this in the output of the name resolving phase, but splitting the analysis into two phases, and the output of the name resolving phase has for each name, this is what it means, but the output of the analysis phase will instead have a different representation of expressions and of all the things I want to keep, so that it only represents things that are possible, which means the left-hand side of a plus cannot be something like a struct. And then I can annotate with all I want, like location information and type information as much as I want, but suddenly I make impossible states unrepresentable. So here, if I want all of those validate functions for sub-expressions to know how to call the sub-expression, yeah, I think I will have to give as argument, I will have to tell them, okay, how do you actually analyze the sub-expression? That, or I give them the already validated sub-expression. That's also a possibility. Because any validation anyway will start by validating the two sub-expressions. So maybe that's what I do. So I change ever so slightly. Sub-expression will be validated recursively like so. Let's name things. And therefore, the validate cast, rather than being given the function to call to recursively... I thought I had changed my settings to avoid that. Ah, well. Rather than being given the function to call to analyze the sub-expression, will already be given the validated sub-expression. Okay. I guess I can replace checked with validated. Okay. Now, I guess for a field access, that's kind of the same thing, I suppose. So that means I can do validated expression by validating the const expression on the left-hand side. Then let's be again very verbose, validate the field access with the validated expression and the name of the field. To do, check that this is a compile time value. Okay. A call expression is something that cannot exist in a function. This will be at some point fatal with a diagnostic, which will be error function call in constant or something like this, but I don't have that yet. So for now, it's unimplemented. For an array expression, I haven't thought about it because arrays are currently unimplemented. So for now, I think I'm just going to leave it as unimplemented. Likewise for index expressions. Now, struct expressions. Will I want to do things differently between a function and a constant? And the answer is yes, but because it is the recursive thing again of I have to use this function and not the other one when analyzing the values of the subfields, I suppose. But beyond that, the validation will be the same. This will be checking the types. Yeah, I think for this one it might be easier to just do the thing where, okay, let's write a function, a struct validation function that is separate, and give it the actual function to call for evaluating the values within. This might be easier. Which means we are back to basically what we had here. I'm delegating the work to other functions to write later. I'm putting more work for future me. But this will be, therefore, a validated struct expression, which will be done by calling validate struct expression, which will take as an argument what function to use for the inner field, which is validate const expression. The path which in the case of a struct expression, okay, that's where it is. It is a path info. Okay. So that should be the struct name, actually. It happens to be a path, but it should be the struct name if everything is fine. And the fields. Then here... Oh, I guess I didn't even need to do that. Because if all the fields have been validated by validate const exp as being a valid compile time value, then the resulting struct expression will be a valid compile time expression. So it becomes just this. Oh, will I want to keep track of R value versus L value? Probably. This might be something I have to keep track of at this stage, because I don't keep track of it during the name resolving phase. I might rename checked to validated. I think that would be better. And I think this will be here in typed. That I will want to add the annotations for L value versus R value, I think. Oh, that, yes, I think. Well, that being said, the goal is at the end to, again, have something in the output that cannot represent something invalid. Therefore, the left-hand side of an assignment will not be an arbitrary expression, it will be an L value expression that I know to be correct. What that means is that maybe I don't need to keep track of, oh, is this thing an L value? What I need to do is, oh, it happens to be on the left-hand side of an expression. Can I convert it to an L value? So maybe I don't need to change the thing I had before, and I can abandon the old thing I had. Okay. Okay. So I think this is fine as it is. Int literal, perfect. There's nothing to change. An int literal is perfect. The only thing is maybe this is no longer the correct representation for it. Again, I'm gonna rename this to validated. I don't like checked. Okay. Okay. So if I look at, because int expression is an old thing that I had in my old code. It was a template alias, I think. Where was it? I don't know where it was. Okay. Oh, it appears in a lot of places. It was in built-in, and it might still be a built-in. Okay. Maybe it needs to change as a result. Because that's a typed expression and that's something that no longer really exists. So maybe this is something that has to go away. Anyway, in the validated form, This will be an int literal expression, but since it's going to be a typed version of this, this is going to be a typed int. So this is going to be typed int type of an int expression of that constant value. Okay. That was the thing for which I was using a pattern before, and I might use a pattern for this in the future just because it's very verbose to write. And this is probably going to be a typed output expression. Okay. So all of those are going to be the same. If I find a Boolean literal, it becomes a typed with a Boolean type of a Boolean expression. Maybe not Boolean expression. Literal expression. Okay. Oh, I might need to, for all of those, prefix them with input, because I want to differentiate between the same name in the input and the output. Not all of them will have a name overlap, but this will be more clear like this. So an int literal expression in the input becomes an int literal expression in the output. Nothing is changed there. Except now this is annotated with type information because a literal int is annotated with the type int. This becomes an output Boolean literal expression. This becomes a typed with character type of an output of this. Strings, I don't have an implementation of strings yet because I don't have an implementation of arrays yet because I don't have an implementation of arbitrarily sized data types yet. So that's gonna happen at some point, but not yet. Do I have in type? I don't have string type yet because I don't support strings yet. So for now, this is unimplemented. A reference expression makes no sense in the context of a constant. References only make sense in the context of a function argument. Therefore, this will be a fatal error reference expression in const expression or something like this that I don't have yet. Now, do I want to delegate Boolean negation and int negation to a separate function? Is there a lot of work to do here in the old core pre-refactor? If I go look at function statements, function expressions, if I look at a Boolean negation, there I have to do some type checking there, I suppose. So I guess I can do. Actually, I need to remember that this is an input. Input. Okay. I'm going to do the same thing, I think. I'm going to delegate to a function that's common across functions and constants and just check after the fact that I do have a actual compile time value. So that means that I replace all of this with validated expression will be the result of calling validate Boolean negation. Actually, it's going to be first validate const expression of the expression, and then the validated Boolean negation will be the result of validate Boolean negation expression with the validated expression, which will be a typed expression that contains type information and everything of the output. Check that this is valid as an argument to a Boolean negation. Give me the return value. To do check that this is indeed a compile time value, which in this case, do I even need to check that? I probably don't, in the sense of like, if this was not a compile time value, I would already have an error at this point, meaning the Boolean negation cannot return anything. Like, this has to return something that is, I guess for sanity checking it will be worth having nonetheless, but this will be useless in this case. And return pure typed Boolean type of, well, actually I don't need to do that. Just return the validated Boolean negation. Gonna be the exact same thing for integer negation. Maybe I should have written those functions as I went, rather than just making this gigantic staircase thing first. I don't know. I think the same thing applies here. For all of those, for all of the operators, I don't need to re-implement everything across functions and constants like I had before. I can duplicate by just analyzing the sub-expressions recursively and then delegating to another function the responsibility of performing the type checks, basically. And then the additional constraint in the constant is checking that the result happens to also be something that is a constant time value, which should always be the case. Actually, do I need to do that? I might not need to do that, those check compile time values thing. Because if recursively validate const expression cannot return something that is not a known compile time value, then is there a single of those operations that can take a known compile time value and not return? So maybe I don't need to check that. Or maybe I just need to do it as a safety measure, basically. Yeah, maybe that's what it is. I just need to do it as a safety measure. So let's go back. This is purely going to be basically a sanity check, const sanity check of the result. Oops. And I guess this could be a good place for an internal compiler error, since I have the strong assumption that all of those will always return valid constant time values, given that at no point, if the assumption is that this function recursively cannot give me a non-constant time value, then any of those validate functions should be able to give me a constant time value. Therefore, unless maybe for Boolean AND and Boolean OR, it might be more complicated. No, I should be able to do that compile time as well. No, okay. So this is just a constancy check, which is technically optional and is just there to ensure, oh, actually, this invariant has been respected, basically. Oh, and maybe I don't need to do it this way then. And like wrapping every single thing in a const validity sanity check. Maybe since this is an invariant of the actual function, then I can probably instead define a helper function like this. Well, maybe not like that, actually. Maybe result is the result of case located of, and I keep the same thing. And after that, or maybe I'll do it this way. Here I'll do a sanity check of the result, where the result is this, basically. Yeah, it's just one level of indentation. Something along those lines. Okay. So now that removes all of those to-dos, which is great. We like to remove them. Here I can just call validate and I can remove this. Validate, I can remove and just remove this. And so here, for most of the binary things, this become the left-hand side is I call validate const expression on E1. Right-hand side is I validate a const expression on E2. And then I validate an addition expression given those two resolved, those two validated left-hand side and right-hand side. Now, for all of the subsequent ones, I might be able to do the same thing I'm doing here, which is use some kind of alias to delegate the thing for me, basically. Because the question is there anything in those that requires... I don't think there is. Mm-hmm. Let me think for a second about how I want to do this. Because I probably don't want to introduce a validate addition expression, validate subtraction expression. That would be a lot of small functions for basically not a lot of gain. Well, I guess. How is this safe div implemented? Okay, that's in core. Yeah, I guess those just report an error, a error divided by 0. Yeah, I think there isn't really a good reason to keep them like separate. I guess from the error reporting perspective, even then, as long as I know the name, maybe that's something that's missing from this would be the name. Because if, for instance, I do a multiplication between things of different types, the error message should be able to contain the information that the erroneous thing is multiplication. What I think I will do is I'm going to change something slightly. I'm going to use a validate expression thing for all of those. So a validate addition expression, validate subtraction expression, and so on. However, those I might generate with another function so that as far as this function is concerned, I am just calling the validation function, but then all of them are implemented by using a template. I think that's the best case where like implementation details such as this don't surface at all within this big case if here. Here, this function only calls validate subtraction, basically. And at the same time, I avoid unnecessary duplication. I think that's the best case. So let's do that. This is going to be more verbose, slightly, but the code will not be more duplicated. Therefore, I think it's the better option. At the risk again of being very verbose, which I think is fine. Oops. The goal of this refactor is to use everything I've learned in the first implementation of the analysis to try to make everything better moving forward. And I think having this big case of of all possible expressions being as small as possible in each case and always just delegating to a dedicated function will go a long way towards making this more readable. I could, however, use, maybe I'll do that. I could use a local helper within this function to know to which one to delegate, which will save me a tiny bit of yeah, I might do that. So binary validate binary exp with some given function e1, e2 will be this, basically. And here we call this f function, which I could rewrite as an applicative, but I prefer this version. It's more readable. Okay. That means here I can rewrite this as validate binary expression with validate addition expression e1, e2. Okay. Oops. Okay. And does that also apply for all the equality expressions and so on? I think so. I think all of them are evaluate the left-hand side recursively, evaluate the right-hand side recursively, and then apply some validation function. So I think I'm just going to continue doing the same thing. Nope, that's not correct. There we go. And this is a difference expression. Oh, actually, I should probably, and I can actually do it as a replacement, I think. I'm just going to do that as a big regex. It's going to be easier than doing this, or at least less tedious. Because I think, yeah, okay, there's only that much left. But still, let's do it as a big regex. I'm going to have a bunch of space I'm going to ignore, a bunch of non-space, which is the name of the expression, of a bunch of space I'm going to ignore, e1, e2, an arrow. And everything that comes after I can safely ignore. And this will be replaced by input of this, e1, e2, an arrow, new line, validate binary expression with the function that is going to be called to validate the result will be... Oh, actually, I could go even further, but I might... Nah, it's fine. This will... I was thinking maybe I can just use I can just use the applicative syntax as a lift A2, basically, to make it a one-liner that doesn't use this validate binary expression with. Maybe. Maybe. Because basically what validate binary expression with is an alias for lift A2 and using... I think it's fine. I think it's fine. I'm going to keep it that way. So the function we're going to call recursively will be validate \1. So validate lesser expression or something like this. E1, E2. And it's validate, not validate. Except for that worked. So again, now the downside is I'm going to have to introduce a validate addition expression, validate subtraction expression. I'm going to have to introduce one such function for each case, even though a lot of them will be extremely similar. But I might be able to just implement all of them with a template. So validate addition expression will just be validate thing with this argument, basically. But that means that for now, at least, this constant handling, constant expression handling function is a lot more readable than it used to be, because it has only one line per case, basically. I guess I have a bunch of places where a do block, where the do block isn't even required anymore. It doesn't hurt to have it, doesn't change anything, but I guess for range expressions, I could almost do the same thing. Where like, yeah, no, those are gonna be the same thing. They're gonna be a validate a binary expression using some third-party function after evaluating recursively. But that's for now. I'm just gonna leave this unimplemented. And all of those are just gonna be, for now, I don't have an error for this, but this is all basically, oops, try to do an assignment expression within a constant. That makes no sense. So we will put a real diagnostic when we have one. There we go. So that's our new validation function for a constant expression. It will require a lot of work. It is very incomplete. Now, this here assumes that type info will be... Is that correct? It looks like it is. Perfect. Okay. So this is basically saying a constant always have a type declared for it. Like const x happens to be an int, and here's its expression. This resolves the type, this resolves the const expression, checks that they're the same, reports an error otherwise, and then does some updating. This might not be done at this level. I'll have to think about it. For now, let's focus on constant expressions. Oh, I have to do the sanity check as well. The sanity check, pure result. And this is going to look at the expression info. Not okay. What's the typed value of the result? And a sanity check is... Actually, instead of doing this, I'm going to say that this is a function. There we go. And this is basically going to be a function that checks that indeed we have a compile time value. That check should not be required. This is why I'm calling it a sanity check. If it's wrong, it's an internal compiler error. Something else went wrong. This is checking a basic, like, what's the word I'm looking for? Invariant of this function. This is a typed thing as an argument. Alright, maybe I don't do that. Maybe I do the result is this and sanity check of the typed value of the result and then return the result. Which means sanity check is just a case. And what are the things that are valid as an expression in the output? If it's a constant, wait, do I want to use a different type for this? Do I want to use a different type for this? So that a constant time expression cannot be represented with an arbitrary expression. If that's the case, then it makes, but it makes, if I do that, then I lose the ability to have my functions that do analysis of a cast or something like this be generic. I lose this ability. Because if I have a dedicated expression type for expressions, for constant expressions, then suddenly, depending on the context, the left-hand side, that the sub-expressions will return a different type. The thing is, the different type only matters insofar as trying to compute a result. So maybe I can actually, because what do the things such as validating an int expression after I've validated the things recursively checks? It checks the types. That's what it does. It checks that this thing is valid in the context. It doesn't need to inspect the values. The only place where it needs to inspect the values is trying to see if they can be computed at compile time, which I guess I could make a type class, which is compile time resolve, basically, that then but it's going to have to do a lot of duplicated stuff if I do that. Maybe not. Maybe not. Well, the duplicated part will be, well, I need to extract an int value from this left thing. I need to extract an int value from this right-hand side thing. Can I do that at compile time or not, basically? I think it's doable. I think it's doable, and therefore I think it might be worth having a const expression in my output. And that happens to be one of those, basically. Is that true? No, it's not. It's not. So I am going to instead duplicate that. A constant expression cannot contain a local variable. A reference. Can it be an index? No, it cannot. It can be a function name. Can it? No, it cannot. No, it cannot because I don't support types to represent function pointers just yet, so it cannot yet. So a constant expression can be an array expression for which I have no support yet, a struct expression that's valid as well, a literal expression, and that's it. But those can contain recursively other things. So those are const expression. There we go. So that's actually a const expression in the output. Okay, that will complexify some things. But the great benefit of this is when I get something here in the output, I know for a fact that I don't have to check that there's a field access expression or something like this in my constant. I know my constant is something that is directly a value because it has to be one of those. There is, however, an issue, which is those constructors are sharing names across types, and that tends to not go very well. So const exp. There we go. Okay. Yeah, it's going to be annoying to write all of those validate functions for each sub-expression so that they work on arbitrary const expression or expression. That's going to be a bit annoying, but not the end of the world. Of course, another solution would be to have these two types be the same, but use like a signal on some of the constructors to make some of them unrepresentable in the context of a const expression, like void or unit, that kind of stuff. And then suddenly the types become the same. We are back to trees that grow again, but for expressions within the context of the output. Do I want to do that? Maybe if it becomes extremely complicated to write the validation functions. We'll see. Okay, for now, I'm gonna keep this. So we go back to here. Sanity check becomes irrelevant. Sanity check becomes irrelevant because by construction, we cannot return a non-constant value from this. So we don't have to check for the invariant. We have used the type system to represent it. So this is just go here. I don't know if I need to keep... doesn't hurt to keep it as a separate function. So I have the helpers here above. Now, that means there's a few places where I'm going to need to change what I return. And for now, those very few places are going to be here. We are returning in... int literal const expr boolean literal const expr. There we go. Okay. So I think for now, we should be able to start doing some of those sub functions there. Hello, how are you? I'm in the middle of a refactor that is a bit of a nightmare because I haven't streamed for like a month. And the last stream was like, oh, let's break everything. Let's refactor everything. And I left the code at the end of the stream in a place where nothing compiled. And then I was gone for a month. So it's like figuring out who made a complete mess, knowing that it's me, but that I don't remember what I did. It's fun. So I'm taking some small steps that I know need to happen, and I'm working on those. And I'm hoping that the bigger things that I'm missing will come back to me as I solve the smaller ones. Here we have rewritten. The context of this is a month ago, I finished the lowering into IR phase, where we take the resolved AST, like after doing all of the analysis, name checking, type checking, and so on, we have an AST, and we turn that into an IR that's basically compatible with the LLVM IR. We did that in a week. I was extremely surprised. But the thing that I really disliked about the way this was implemented is a ton of internal compiler errors within the code of the lowering into IR. For instance, I have an expression that is an assignment. Well, if the left-hand side of that assignment is not something that's valid on the left-hand side, then internal compiler error, right? In a sense of like, the compiler should have checked that this was valid. And since I know it has, hello everyone. I have been gone for a month, which might be why maybe your follow dropped. But yeah, welcome everyone. I was not explaining why I started a big refactor a month ago that I'm still in the middle of, basically. And the short of it is the old version of the analysis that does like name checking, type checking, and so on, did not have a good way of capturing the results of the analysis. That means that the types I had in the output still contained things that could still represent things that didn't make sense. To give you an idea, if I go to common, here, this expression type, which is used as the output of the parsing phase, a valid thing would be an assignment expression. That's a valid expression in the output of the parsing phase. And the left-hand side is an expression, because what we assign things to can be different expressions. Can be a variable, can be an index into an array, it can be a field access into a struct, like it can be a lot of different things. Yeah, well, thank you for dropping in, and thank you for rating. So this is a perfectly valid way of representing the output of the parse phase. The left-hand side of an assign, yeah, it can be any expression. However, when I have performed all of the analysis, I know that the left-hand side of an assign cannot be anything. It cannot be, a subtraction. That makes no sense. But since I was using this very type in the output, all of my lowering into IR code had to be like, oh, this is an assignment. What is the left-hand side? Is it a subtraction? If yes, internal compiler error, because we should have detected this ahead of time. So what I'm changing is I'm splitting the analysis phase into two stages, name resolving and then type checking, basically. and I'm changing the types in the output to better reflect what's valid and what's not. In the new type, here's the expression type, which is very similar. However, in the assignment expression, the left-hand side is not an arbitrary expression, it's an L-value expression, which is a different type in which we know for a fact that the thing, by construction, is a valid L-value. Which means, once we're done with this refactor, and we can rewrite the lowering into AR, the lowering into AR doesn't have to be like, oh, internal compiler error on half the things here, because the types we'll have in the output of the analysis phase cannot represent something that is wrong, basically. Or at least can represent way fewer wrong things. Likewise, for constants, the output of a constant will be a const expression, not an expression, and therefore cannot contain things such as function calls or anything like this, because by construction, I know that those things are impossible to represent. So that's the goal of this refactor. This evening, I've done this gigantic function on like, okay, we find an expression in the context of a constant, let's validate it. Most of it has been delegating to other functions, but it's still some work towards making this happen. So now we can start writing some of the... Actually, do I want to start? Because the goal of me delegating to like other functions, like validate a cast, validate a field access, is that the validation logic will be the same across functions and constants. Like validating that a field access makes sense is the same logic across the two of them. The left-hand side must be a struct. The name of the field must be valid in the struct. The only problem is that in the context of a constant, the left-hand side will be a const expression, and in the context of a function, the left-hand side will be an expression. Therefore, I will have to do some shenanigans to be able to decide to perform the analysis and then return a valid value. So maybe actually let's try to implement something in the easy ones. Let's try to implement validate cast and see where we struggle to then figure out how we want to approach those functions at large. So validating a cast. In a lot of places, I have called those validate with, I have suffixed them with expr, so I should probably be consistent. And therefore, do that for all of them. So validating a cast will be something. For now, since the code is not anywhere near compiling, I have just this basic constraint. What will be my left-hand side? It will be a typed of some kind of expression, which will be either a const expression or an actual expression in the case of a function. And the output of this, it also, of course, takes the type, I suppose? Did I validate the type? No, I didn't. But I guess that can be done as part of this thing, yeah. Okay. So this takes not the resolved type, the validated type, it takes the type as provided as the input to this phase. So it is a path info, not a type. It is a path info resolved. And the output of this will be a typed expression of the same type. Which means I will probably need for the purpose of resolving the value at compile time, if that's possible, I will need to use some type class magic on this. I have not yet figured out how we're gonna do that. We'll get there when we get there. So here I have the validated expression, and I have the target type. I suppose the very first thing I have to do would be validating the type. Like, is this thing a type? That one is already written. I'm not sure it's correct yet, but at least some of the work is there. Like, did I find that this was something pointing to a built-in type? Perfect, that's the type that we have in the output. Did I find a struct? Then I can create the corresponding type based on the name of that struct, and so on. I guess type alias is all of those are base name. This is not valid Haskell. This is valid. I definitely left this in the middle of refactor. There we go. That's valid Haskell now. Some of it is unimplemented. We'll have to go back to this. But basically, I can assume that this gives me a type that has been validated. So I know that this target type was valid, or the function has short-circuited with an error if this type was not. So now I have an expression and a type. Could I try? I've changed as part of this refactor how my error handling works. Would it make sense in the case of a cast to try to recover from, like, try to analyze the expression on the left hand side, and if it fails, if it gives me an error, still try to resolve the type on the right hand side, so that if it fails, I have reported errors in both cases. Maybe that makes sense? If that's the case, I will probably want then to have this function take both of the resolved things. Let me think about this for a second. Where have I used? And the thing is, I have not yet defined how this monad works, because again, this was left kind of in a bad state. Because I will want to have something like try, basically, that is able to recover from something that has failed. But I will need to have a way to fail no matter what if something and the question is, do I have a name for that already? I don't think I do, actually. Or maybe I do. Maybe I did something as part of the resolving phase? I did not. I might have actually. I have this use of get compose to compose the maybes and everything. I have this call to ensure here. But this might not be something that I have. This might be the name I have chosen, and I might not have actually implemented ensure in the new version. Because that's something in the old monad, I think. Yeah, I think that's the old code, but at least that gives me the name I have chosen, which means I can use the same naming convention here, and then I'll be able to just I'll know what to implement when I need to implement it, basically. So that means this becomes try, and then so that gives me two maybe values. And I guess then this becomes an ensure of lift A2 of F into those two things. So I lift F to operate within the maybe. So this function from two arguments A, B that gives me a C becomes a function from maybe A, maybe B that gives me a maybe C. And it's gonna give me a maybe value only if both of the arguments were true, therefore both of them gave me something. Then I know that if I have a maybe just a value, it meant both of those values could be computed. Therefore, I can compute this value. If any of them failed, the function is not called. I don't have a value, and the whole thing fails. So that allows me to collect errors on both the left hand side and the right hand side as much as possible. So it's basically automatically trying to recover from errors, but, well, as only long enough just to try the other thing, basically. Which will allow to surface more errors rather than short-circuiting out of an expression immediately. Okay, so I just need to do that in a few more places. I need to do it in the few places that have two arguments that have not been covered by this validate binary expression with. And that should basically only be cast. Unless I do things such as resolving the struct name. No, I think it makes sense to short circuit if the struct name makes no sense, because but I can let this function decide how to do it, basically. Okay, so here that means validated type will be the result of try validate type of the target type. I'll try here as well. And then here, I will ensure the result of lift A to a validate cast expression on the validated expression and the validated type. There we go. So that means I have to change this. This takes an actual type here, because validate type gave me an actual type. Okay. And now what do we do here? Well, let's go back to the old code. And let's look at a function expression, which is this. And let's look at how casts are implemented in this nonsense. I copy all of this into here. So the resolved expression, resolved target type, none of this is required in this context. Because we already have resolved everything. So what do we do? Ah, I do something different. This is, am I casting from enum to enum? Am I casting from not an enum to an enum? Am I casting from an enum to not an enum? And am I casting from not an enum to not an enum? That's what I'm doing. Okay. Since I have a type, lookup enum type is going to be a lot easier because my type, where is it? Here. Basically, this is just is the case here enum type, basically. So I could probably simply rewrite this as being a case of the two values and handle all four branches, basically. Enum, 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 non-enum, non-enum, enum, and neither, neither, basically. Can this placeholder be part of the output? I think the answer is no. I think this makes no sense. I think this should be removed. I think this is a remnant of the previous version of the code. So, since it is a typed expression, I can therefore rewrite this as being a case of the source type, which is the type info of the validated expression, and the validated type, and I want to handle the two cases where I have an enum type on both sides. Where we have, oops, I'm actually, do I want to be more specific? Because I could just list all the valid combinations, basically, and then have a catch-all for, hey, this combination happens to not be valid. Maybe that would make more sense? Maybe that would make more sense, yeah. It's a bit verbose, though, is the thing. At the same time, this is basically what I'm doing, just with more steps. And I guess there's also the question of like, how do I compute the compile time value when it can be computed? Okay. Okay, I suppose let's try basically this. Let's try the full case thing. So that's the possible things. Let's put all of the ones that can appear on the left-hand side. Can I cast from unit? Can I ever do that? Technically, I guess I can cast unit into unit. That's valid. But will I ever want to allow that? Did I allow it before? And I think the answer is no, I did not. So unit type isn't something that makes sense. I have to handle void type, however. Void type is a valid cast as a source. If something has the type void type, it means it doesn't matter what it is the result of a panic. Basically, the built in panic functions and other things like this will return something of type void, which is compatible with everything, which is how Rust implements panic as well. So, if I have like a function that may return an int or panic or something like this, well, that function returns something that is an int, I suppose. If I have an expression, I don't have ternary expressions, I guess. I guess it's not really possible in the language as it is right now, but we could imagine if I had like a ternary expression or something like this, like a equals some ternary thing, which would happen to be int or panic or something like this, I would be able to then cast that as something else because the panic is compatible with int basically. So casting the result of panic as something else, fine. So void is a valid thing to see on the left hand side. Enum is absolutely valid to see on the left hand side. Struct might not be. I don't think I want to allow casts of struct. I didn't before. The only reason why I think I could allow cast of structs is to allow casts between structs that have the exact same representation. Like this function uses a point thing and the other thing expects a vector, and point and vector happen to be struct that contains two ints, then I suppose a cast from point to vector would make sense. I don't support that yet. I don't think I want to support that in this version of the language. So, nope. Struct type not allowed. Function type not allowed. So that is all of the valid cases for the left-hand side. Now, do I want to write them as like case of the left-hand side and then a sub-case for the right-hand side, or do I just want to write all of the possible combinations? I think I want to write all the combinations. It's easier. Then I don't have to write a catch all case in like a default case in all branches. So an int can go to an in of course. Oh, this is target type, source type. Okay. Yeah, everything can go into an int, basically. That's all fine because they all have like an int representation underneath. Okay, so an int can go into an int. Int can actually go into a boolean. Can an int go into a character? No, I think that makes no sense. Wait, no, it can, of course. Obviously, no, it can. That's just the converting the ASCII value, basically. So that will be a branch we have to accept. Void type is not a valid target, however. And converting to an enum is, of course, valid. Okay, that's for ints. Boolean can go into an int. Boolean can go into a boolean. That should be obvious. Do I want to have? I can't really easily write a. Those two values are the same on both sides. It's a shame. Can I convert a boolean into a character? No, I think that one makes no sense. And I don't think I can convert a boolean into an arbitrary other enum, can I? Can I do that? Does that make sense? Did I allow it before? I did allow it before. Okay, interesting. What does if I have, what's the syntax for enums in Rust again? If I have color, it's gonna be something like red, green, blue or something. Oops. And that would be then a 0 as color or something like this. It's been too long since I've written a lot of Rust. It might just be that. Oh, there we go. Yes. Doesn't implement display. What's the syntax again? It's not derive. It's not imp. Is it imp? No, I don't think that's correct. It's been too long since I've written Rust. Derive. It was derive. Okay. Except display is not in scope. It is. I need to use. Isn't from it? Ah. Oh, of course. I'll get there. Why is that not correct? I must be doing something wrong. Oh, am I? Oh, is it just like it cannot be derived? Oh, maybe it cannot be derived and just debug can be derived but not format? Maybe that's what it is. Okay, let's just do a derive debug and use this syntax. So I'm not interested in actually, come on. Non-primitive cast. Oh, interesting. So I cannot cast to enums in Rust at all. Okay, so this would not be allowed as a basic cast. Unless I do an unsafe transmute. Okay, so Rust doesn't allow casting to enums at all. So it means I'm free to basically, since I want to allow it, I'm free to decide what I want to allow and what I don't want to allow, basically. And I think casting a boolean to an enum doesn't make sense. And I think if someone wants to do that, they should do as int as enum for that to be explicit. So boolean to characters make no sense. Boolean to void not allowed. Boolean to enum not allowed. Boolean can only go to int or to boolean. Character type can go to int, can go to character, cannot go to boolean, cannot go to void, cannot go to enum. Void type doesn't. Void type goes to basically anything. So I think void type can be a catch-all, basically. Void type can just go to literally anything. And then enums can go to int. And enums can go to enums. And that's about it. Okay, so that is, and any other case will be the bad cast, which is this. Except those types will have to be different. So I'll have to change this to be, oops, what was the order again? Source target. So it's those basically. Okay. Now, all of those other cases, this is a valid cast. Now is where we have the difficulty, which is, why do I have more here? Which is that I have validated that the type is correct, but I need to also create the result expression. But I don't know what the type of the result expression is, because it could either be a const expression or it could be an actual expression. And those are different. Except, do I need to change? Well, yes. In the case of a function expression, I want to emit a cast unless I can simplify the value. Therefore, meanwhile, in the case of a constant expression, I don't want to emit a cast. I want to inline with the actual result. So this might be where my plan of reusing functions across constants and functions fails, because here I have to basically re-implement this anyway. What's the worst? What's worse? Duplicating this kind of like cast, like big case, because I want to do something slightly differently in a case of a constant and in a case of a function, or better to keep this once to avoid duplicating it, but then having complicated type class logic to know how to create the value out of whatever this thing ends up being, basically. I think since some of the issues that motivated the refactor was the code of the analysis is too complicated, I think I am slightly in favor of not doing any type class magic. And therefore, this is a constant specific function. And I'll have to write a different function which is going to have the same structure for functions. And maybe what I'll do is I'll just introduce, rather than using type class magic, I'll introduce a common function that takes as arguments the different possibilities. Maybe something like that. Yeah, okay. So there's still a few places that are trivial. If I'm casting an int into an int, the result is the expression on the left-hand side. Nothing needs to change. A boolean into a boolean, that's the same. A character into a character, that's the same. That's perfectly fine. I can probably get rid of almost all of this. Because a lot of that logic was about handling type parameters, which is a thing I don't have to handle anymore since I'm no longer doing type checking of generic functions until they are instantiated. Yeah, a lot of this was also like carrying R value information, which I no longer need to carry. Yeah, a lot of this was handling things that no longer need to be handled, so I'm just gonna get rid of all of this. I'm just gonna put it on a new line. In case of trying to convert something that I know happens to be void type into anything, the result will still be void, the result will still be invalid. So this is also a case where like, yep, casting. But do I want... The problem of doing this is I'm allowing doing like a cast from panic to struct, basically. I'm allowing casts that are not supposed to be allowed. So I probably want to avoid that. I should probably be explicit. But that's the problem. With void, I don't know what the... But if I know for sure it's void, it's fine. It can be anything. Although maybe I just don't want to allow it. An explicit void only happens... An explicit void only happens as a result of calling a panic manually. And since I don't have ternary expressions or anything like this, and even if I had, do I want to allow basically a cast of an explicit void? Is that something that makes sense? Maybe I don't actually. Did I before? I think I didn't. Maybe it makes no sense. And I don't have to handle it. Okay. Okay, so the easy thing about this is that all of those values share the fact that like they have to go through int representation for all of this, basically. So I can basically on all of them do give me the int value that maps to this thing, and for the left hand side, and then try for the right hand side, basically. Like this is gonna be something like 2 boolean of get int value or something like this of, let's say, the typed value of the validated expression. This is why trying to do this for the case, but this is again, in the case of a function, I'll try to do the same thing. As in, can I write this? I'll think about it later. When I write the validate cast expression for a function, I'll think about the structure is going to be the same. Can I deduplicate it, basically? And I think the answer is simply going to be having this return a maybe, having a get int, like making those functions like deal with maybes, basically. And in the context of a function, if I don't get a value, it means the value was not known at compile time, therefore default to a cast that has to be delegated to the lowering into AR at a later stage, basically. Do I need to emit a cast for the IR? Can the cast just be elided? Because the implication of a cast is that the underlying representation is similar. Well, no, it's not necessarily. It means they're compatible, but some operations might need to happen. Like bounds checking will need to happen at runtime for cast CNMs. No, I need to emit a cast. If I can't, I can't just like remove the cast. Okay. Let's write it for constants. When we get to functions, I'll see how to deduplicate. Let's not do things ahead of time. Now, that's going to be that. And I suppose I can just... I don't need... I can just say int value. Do I need the enum name? I think I don't. I only care about the values. And on the left-hand side, I don't think I even care about the value. So here, this is going to be a toEnum with the enum values of the int value. To boolean. Well, do I need to do that? I don't even need to do that. I can just do this, Boolean result, car result, enum result with the enum values, Boolean result. Well, int result is trivial, but I'm still gonna write it like this. Character result. And this is actually, I think, how we're gonna implement this across the different things. I'll just have to give those things as argument to the function. Okay. So I'm converting some kind of enum to an int that is valid, and that's the int result. Oh, this is wrong. This is an int result. Okay. And that's the enum result with the enum values. Okay. Now, we need first get int value, which is going to be something that inspects the constant expression and will give me something that can be converted into an int. So this is, let's do a case of the typed value of the validated expression. And I know that to be a constant expression. So it's one of those. Maybe when I have arrays, I will allow cast of arrays as long as the values within can be converted. Unless I have heterogeneous arrays, but I don't think I will have that. But that is simply one of those. If it's a Boolean, the result is it is a from enum of that value. If it's an int, that's trivial. That's the int. If it's a character, it's trivial. It's the order value of the character. If it's anything else, that means we failed. I could be an enum, I suppose. I went a bit too... Oh, but an enum will be represented as an int literal underneath, so that's fine. So if it's anything else, it means we try to extract a value that happens to be from an array or a struct or a string, despite the fact that those are never allowed on the left-hand side, so something went wrong, so that's an internal compiler error. The only thing is I want to make sure that this value is lazy, so maybe I'm going to make it monadic, so it's only evaluated when required. Although it should be fine. It should never. I might not need to do that. It will not be evaluated until it's required, so I don't need to do that. It's fine. In all other cases, report ICE. I don't remember the syntax of this. So let's have a look at how I've used it in resolution. It is the name of what I'm doing, and then an error message, and then some additional random arguments. Okay. So this is const cast validation. The error is unexpected left-hand side. And the details are going to be, let's do quickly a git grep with after, let's say 5 of report ice. See what it looks like when I give error messages. It's purely strings. Okay, it's purely strings. So I suppose I can just do that. I can just show the whole thing. Okay. So that's okay. We had something on the left-hand side that we didn't detect as part of this. That's an internal compiler error. Because normally any kind of wrong... Oh, hello, how are you? Any kind of wrong cast should have been caught by this. Therefore, if we ever end up in this case, that's an internal compiler error. Then, what do we have? So an int result is going to be simply, it's going to be trivial. It's going to be pure, and we're going to be outputting a typed thing, the type of which will be an int type. And, oh, maybe I will need a name actually for the enum because of this. Unless I don't bother with this. Yeah, since I will always have validated the target, actually I'm gonna rename this target type for clarity. So all of those will always be a typed value containing the target type. And what changes is simply what kind of value is within. So for an int, it will be an int output int literal expression, const expression, where the value is the int value, which will then be evaluated here. Okay. A character result to the point where, since the typed is always going to be there, I'm tempted to actually do get the inner value out of this. And always return. My indentation is wrong. There we go. Pure of typed target type inner value. And that means here I don't have to worry about this. Int result is just pure. There we go. Character result is pure output, and it's going to be a character literal const expression. And this is going to be doing this on the int value. And a Boolean result is going to be simply of int value different from 0. And that's I guess for the inner, then I need to return the actual. It's a bit annoying, but it's not the end of the world. Here I need to return. I need to return the inner value, which is. I guess I could just do. Rather than trying to make something specific, I can just do the same logic. Boolean result. That means I'm doing some unnecessary conversions, but that's kind of trivial anyway. It's not the worst, actually. This provides a sanity check. It means if I'm converting and casting a boolean into a boolean, I'm still gonna check that I do have a boolean constant within and not something else. So this will provide the sanity check. So this might actually be better. Okay. So the only thing I'm missing is, and I'm gonna, I think, group them together, is the cast into an enum. This is the tricky one. This is where I'm gonna go back to look at the code that I had before the refactor. To go look at this compile time enum cast. I'm just gonna copy that and simplify it. Because this is. That's a basic if. If the int value is less than 0 or it is greater than the or equal to the length of the values, then report an error. I try to cast 3 into a enum that only accepts 0, 1, 2. Oh, this requires the enum info. I might not have the enum info. Maybe the enum name would be enough. What is an enum name in this case? It will be a name. Okay. So I will need here name, enum name, and I will need to give that name here. That's going to be the name and the int value. Otherwise, I can cast this 3 into an enum because that's a valid value. What do I return? I actually return an int expression because enums are just ints under the hood. So it's an int literal const expression of the int value. Okay, so that's the cast function that checks a compile time cast in the context of the expression of a constant. I will want to deduplicate this because this is currently actually for a const expression. But I will want to also handle this for normal expressions, and the difference will be that basically this thing might, yeah, I suppose. How do I do this? I am trying to figure out how to write a generic function that does this kind of analysis on the cast without hard coding whether the input is a const expression or an expression. And I think what I need to do, it's going to be a bit verbose, but I think it's better. It's going to be to have a generic one, which takes some arbitrary expression there. And the type, and then takes. No, this is in M. This is an analyze. A validate M. This. I suppose it needs to take monadic actions for how to construct the results, basically. So it needs to take a few of those. For int, character, boolean, and enum. Except that last one requires the enum type information, basically. Which is, again, this. And it will be able to output none of those. This. Except not a const expression. It needs to be that expression type. Regardless of what it is. And so this becomes int result, boolean, character result, boolean result, enum result, become argument to this function. And then this disappears. So this function is purely doing the check on the types, delegates to the given argument how to construct the result for the given expression type, and calls the correct one depending on the branch. And if it is an invalid cast, then fatal, rebus an error. And otherwise, creates a new typed value containing the correct inner value. And that means a validate const cast expression doesn't have to do any of this. It can call validate cast expression with the validated expression and the target type, but it needs to give the int result, the character result, the Boolean result and the enum result. There we go. And so how to construct the result will be specific to the const expression, and the validate function cast expression, I suppose, will be something like that, except it will have an expression as input, expression as output. It will be a validate cast expression. Was it? Oops, validated expression here and validated expression here. The target type and everything. Nothing else has changed. All of this is the same. But how to extract the int result, character result, boolean result, and enum result will have changed based on whether. So int value will have to be different. Int value will have to be something along those lines, except const doesn't have to be, doesn't exist. It's going to be something like that. And either I can get a compile time value and this will be right this, or I cannot, and that's not an internal compiler error. It just means that's not a compile time value. So I have some kind of expression, runtime expression, whatever it is. And that's going to be some expression. That's perfectly fine. I guess this is just going to be left of the of that expression, I suppose. And as a result, the int result will be if we can, if we have a compile time value, then we can compile, we can cast it at compile time. Oh, I suppose this is not entirely true. No, it is. It is. It is because the inner value will be a cast in the case. Yeah, okay. So here, do I need to make this a monadic thing? It doesn't have to be a monadic thing at all, I think. I don't know, it has to be because some of them might need to report errors. Yeah, it needs to be monadic. So the case of an int result for a function will be, do I write it explicitly? Or do I use either? I'm just tempted to use either. And it's the left case first. Okay. So if I have, no, actually, let's write it explicitly. This is going to be a case of the int value of left expression. I have a runtime expression that I cannot investigate. The output will therefore be a cast expression because the cast needs to be maintained, and that's going to be this thing. Where is the cast? Cast, there we go, to a type. From the validated expression. It's going to be that for all of them, actually. Maybe I will want to introduce a... maybe I don't want to do this. Maybe I will want to do get result with f, and f will be how to wrap the result to create an expression. And in the general case, it will just be a cast expression from the validated expression with the target type. And int result will therefore be result with this is going to be a pure because this cannot fail, and therefore this is the monadic function. Result with, and in the case of an int, what we are doing is pure of this. So result with, and either we get a cast expression or we apply this on the inner int value if it's known at compile time. Character result is gonna be similar, except we are doing this. Boolean result is going to be similar, except this is a character result, and none of those are constant. This is a Boolean literal without constant, and we are doing different from 0. Okay. And here, this is going to be a tiny bit different. Result with, and here I get the value. And what I do is this. If v less than 0, if v. So there's a tiny bit of duplication between the two of them, but not the main big tree of things that we support is the same across both of them. What is different is in the case of a const cast, this is how we create the result value by extracting the value at compile time. In the case of a cast of a normal expression of a function, this is how we create the function at possibly at runtime, because we might not be able to have the information at compile time. Okay. Okay. And all of this is now the new version of both casts, where this mess is just a cast for functions pre-refactor. So that is huge progress. Okay. Next, what time is it? It's not too late yet. I can do a tiny bit more. So I need to go back and validate a const cast expression, or cast const expression, probably. Nope, I did the other way around. Okay. Now. Do I want to do them in order? The only thing is, I'm afraid of this one being actually difficult, which is why I haven't done it yet. Oops. It is indeed my turn to play at board games. Let's try that one still. Const path expression. This one will be taking as an argument, I think that's just the same thing as a type. It is a path info resolved. Wait. Are path expressions even allowed in constants? Yes, they are for other constants, but not for anything else. And the output will be, in my validate monad, a typed output const expression. And I guess this is basically just a big case switch again. Well, not directly on this, but on what the path info contains. So if I look at this, and I copy that, the path params are irrelevant. I can ignore them. I need to decompose the path info. I'm just going to copy this. Because the path parameters are only used for things like, when will a path have path parameters? When calling a function, when calling a struct? Oh, actually, no. A struct expression can be in a const expression, but that would not be a path expression, it would be a struct expression. Those are different. Path expression is, I've just literally found the name of something, and the name of that something cannot be anything but a constant, I think. If we go look at what we have before, resolve const value. This was part of context, I think. Yep, it was. This was the very complicated stuff that was looking at definitions because it was both performing name resolving and type checking at the same time. And the only thing that was valid was it is an enum value or it's a const definition. Yep. So, since in this context, in post refactor, I know that this is already resolved. Yeah, I can remove this. I hope I didn't remove it from the wrong place. Nope, I didn't. So the only valid things would be pointing to an enum. And even then, I will have to check that I'm pointing to an enum value and not to a to the name of the enum. That's the thing I'll have to check here. Or I am pointing to a constant. Everything else is wrong. If I'm pointing to a built-in type, that's not valid in a constant. If I'm pointing to a struct, that's not valid in a constant. Built-in function, type alias, type parameter, placeholder. Yeah, none of those make sense in a function. Some of them are even absolutely impossible, like a function argument. Do I want to differentiate them like, oh, this one is an internal compiler error because it cannot happen given the definition of the language? Or since most of those branches end up reporting an error anyway, do I want to just bundle them in? The only downside of just having a catch-all there is if something extremely wrong happens where I end up having a path being resolved to a let variable inside a const expression, which is impossible, I will not detect that this happened because I'll be like, that's not a valid thing here, basically. Yeah, I think I'm just gonna not a const the thing. Anything else? Report error, not a const. What does it take as an argument? The name, the path name, which is path name is the path info. Okay. So it's this basically. It's the left hand side. So that's the role actually. Up. So this will be an error that reads expecting a constant value and found whatever this happens to be. So those are the two only cases we need to accept. Verify enum value, verify const value. Let's check verify const value, I suppose, first. What needs to happen here? Oh yeah, I suppose that makes sense. Okay. So here this will be... I guess I can do that already. I don't need to do that before. I can do a... Well, I guess it makes no sense to do that check if the thing is wrong anyway. As in, if I'm pointing to a struct, maybe the number of parameters is correct. That check only makes sense when I have validated it is already an enum or a constant. So maybe I'll adopt the thing I had, even though I'm gonna do it slightly differently. I'm gonna introduce validate const enum value and validate const value. Base name params. Except the params are the path params. Okay. And here I'm gonna make those local. Validate const value. So I have the name. And this is gonna be where I'm actually gonna do a validate params function. Which is gonna be the trivial thing of just if this happens to have a non-zero amount of parameters, that's just wrong. And I guess those don't have to be names, they can be base names, they are just actual names, I suppose. Since I'm expecting params to actually be 0. Okay. So when I validate a const value, what an incredible function name, I validate the parameters. And then I need to create... Okay, I have checked that this thing is a function. I need to output a typed expression in the output. But this is where I will need to do, and I haven't thought about this yet because this has changed completely since last time, I will need to go recursively validate the other constant, therefore check it in the cache, and detect loops. Because if a constant A calls to a constant B that calls to a constant A, I will not be able to compute the value at compile time. So this is a part I am not going to do the same thing. Because I don't have the infrastructure in place yet. And validating a const enum value, give them some names and parameters, will be validating the parameters in the first place, which is going to be that there is none. And what will it be afterwards? Validate enum value. What's it called? Const value. Verify enum value is the one I'm looking. Yes. Okay. So this is what I have to do. Aha, okay. So this is the thing where I need to figure out whether the name I have, because I use this thing called a name, which contains a base name and parameters, and this uniquely identifies something within the context of our program. So for instance, if I have a function foo in a module bar, and that function foo is parameterized by a type t, when it gets instantiated to int, the unique name that will point to that symbol in the compilation unit will be base name bar and name foo with parameter int, basically. So that's a thing that uniquely identifies the symbol within the context. Now, for enums, I do something slightly tricky where I use the enum name. Actually, I'm wait. The logic is the enum name will be here the identifier that uniquely identifies the enum, but the constructors will be things in the scope. However, do I have them as constants? I think I have them as constants. So if I have them as constants, then I don't have to do any of this. That's great. Because this all goes away. Because that all goes away because the constant will just happen to be a constant in the scope, which is a constant of type, yeah, I think that's what I'm going to do. I'm going to put them in the scope as being constant rather than being being enums, I think. Let me think about this for a second. Let's go back to resolved. The problem is if I do this, then constant points to the unique declaration. So that's not entirely correct either, I suppose. I'll just need to have just one layer of indirection, basically. No, I think it's fine. I think it's fine. I can have at my top level scope enum values exported as kind of constants, basically. And if I do that, then here when I'm calling a a const value. If I find the name of the enum, it will point to an enum, which is wrong. And if it finds something that points to a constant, that's perfectly fine. And I just need to validate recursively. Okay, a lot easier. Perfect. And I can remove this validate params altogether, because this is now just this, and the path params are always going to be known anyway. It was already used anyway. Perfect. Okay, there we go. So that's a lot easier. A path within a constant must be another function, which will go into validating that other constant recursively. And if this creates a cycle, boom. Okay. What time is it? Let's have a look quickly. So const path expression done, cast expression done. Field expressions, those might be tricky, but I can get started. So there's probably going to be a const field access expression. I might, like, I'm putting all of this in the top level validation. I might break this down into other files at some point. Maybe one for expressions, because this is getting verbose. But a big point of this refactor is I'm okay with verbosity. I want the code to be simpler. And I think this big case of I delegate to other functions, a lot more readable than the big mess where everything was inlined in the previous version. So that's basically like 1 or maybe 2 lines per case. So let's do a validate const field access expression. That's going to be a function that's in some basic monad m that will actually have more constraints at some point later on, but that's not here or there. Takes as an argument a typed const expression, which is our left-hand side. We have validated that. That is a constant value. And the right-hand side, which I think is just a name. This is an input field access expression. Let's go to resolved. Let's go to common. Field access expression is an identifier. I was wrong. Cast, it's below here. So that's an identifier. And the result of this will be in our validate monad, on top of whatever the underlying monad m is, this constraint will change to be like a monad error handling or whatever, or a compiler monad or something like this, which is not the case at the moment. It will be later on. And this will return a new typed const expression. Okay. So how do I validate a field access expression with a validated expression on the left and a field name on the right? Let's go look at the old code pre-refactor, which will have field access expression here. Yeah, that feels about right. Is the thing on the left a struct? Then if yes, I can try to access the field. If it's not a struct, that's wrong. So I can just copy that. But it might end up being simpler. So here, what I'm doing the thing on is I am ignoring the type entirely. I don't care about the type of the thing I have on the left, because the only thing I care about is the value. this validated expression, and I know that it is a const expression, so it has to be one of those, an array, struct, or one of those literals, and the only valid one is a struct const expression. Name, struct info, and the fields. The fields carry the names, yes. If it's not a struct const expression, then error field access not a struct. That's correct. What's the error field access not a struct? It is the path info resolved. I think that's no longer correct. This will have to be... Yeah, this is no longer correct. This is going to be annoying. This is going to be the thing where I will need to have either a const expression or an expression. I guess it could just be the type. And if it's just a type, then that's just a type. And that will happen to be the type info of the validated expression. Likewise here. And I think the type contains, yeah, it contains all of the information about the struct, so it's going to be enough for the error message. That's perfect. Okay, so what am I doing here? I am doing a find. Yes, okay. This is not very readable. Can I make it more readable? This will be field name ignored, field value. This will be the result of doing a find. Find field name equals first on the fields. So I have the fields of the structure. I'm doing a find to find whichever one happens to have as the first element of the pair the field name, which means here, whatever this gives me has to be the field name and the field value, which is what I care about. However, this find might fail. It might not be able to find the field if there has been an error, and that's the on nothing. On the case where this gives me nothing, I do a fatal error with this field name. And in the case where I got this, I return the field value, which will be a typed const expression, which is what we want to return. There we go. Okay. There again, I will probably want to figure out a way to try to deduplicate this for functions. Because functions, it's going to be roughly the same thing. Wait. No, it's going to be more complicated for functions. So maybe it's fine to have a different function there. Because for functions, I'll have to check Yeah, for functions, I'll have to check, do I have a struct on the left-hand side that's perfect, I can do the exact same thing, or do I have something whose type happens to be struct, and then I need to go get the type information. Because that will be fine, it will be part of the type. Okay. So I can probably do a validate. What has been my naming convention? Const and function. So I can probably easily do a validate function field access expression with the same principle here. If I find a struct expression that's perfect, I can just extract the thing and return the compiled and known value. Or, in the other case, let's go see what core was doing. In the case of functions, in the case of a field access expression, we would do a check struct type, and if that gives me nothing, it means I didn't know that the thing was a struct, which could only happen when trying to resolve uninstantiated generic functions, which cannot happen anymore, so that's fine. So now we can inspect the type, which must be known, and we need to know that it happens to be. So the thing on the left-hand side, the type must be struct. So I can do a case on the type, and yeah, okay. It's going to be something along those lines. Ah, but this is where the parameter mapping will get into. Wait. The parameter mapping will only happen in the case of a struct literal, I guess. I'll have to think about it. Okay, I'm not going to do it this evening. Because how to do the parameter mapping has changed completely since the previous version. So I'm just going to leave it unimplemented for now. Okay. I think I'm going to stop here for this evening. But this is good progress. It's going to take a while to get to a point where we can even try to compile. Because, again, I broke everything. I took apart everything that was working and tried to fix everything all at once. So the code is a gigantic nightmare at the moment. I might push it on a branch just to have a copy that's not on this computer in case something happens. But I'll be back next week now that my health is a bit back on track. Sorry again for like the month-long interruption. That sucked for me as well because again I've lost all the context of what I was working on. But now that my health is kind of back on track, I'll be back next week to continue on this and might do a bit more than 2 streams a week if I can. Because it is exciting to have to redo things with the hindsight of knowing what to fix, basically. But yeah. Thank you everyone for tuning in. I'll make sure to update the YouTube channel with all of the. I did get everything in time before Twitch erased um, the recordings, so I have all of the recordings. I just need to publish them on YouTube. So I'll try to do that, if not before this weekend, before next stream. In the meantime, thank you for tuning in, and I'll see you next week.